Whenever liquid is mentioned, one immediately thinks of a very fluid substance. Whereas the fact is that the viscosity levels of liquids differ greatly. For instance, the viscosities of tar, glycerine, olive oil, and sulfuric acid are all very different. Enormous differences emerge when these liquids are compared. That is because water is 10 billion times more fluid than tar, 1,000 times more than glycerine, 100 times more than olive oil, and 25 times more than sulfuric acid. So what is the importance of water's low level of viscosity for us? If this vital liquid were a little more or less viscous, would it make a great difference to us? Professor of Microbiology Michael Denton supplies the answer. If the viscosity was higher, the controlled movement of large macromolecules and particularly structures such as mitochondria and small organelles would be impossible, as would processes like cell division. All the vital activities of the cell would be effectively frozen, and cellular life of any sort remotely resembling that with which we are familiar would be impossible. The development of higher organisms, which is critically dependent on the ability of cells to move and crawl around during embryogenesis, would certainly be impossible if the viscosity of water was even slightly greater than it is. Water's low viscosity is essential not only for cellular motion, but also for the circulatory system. There are a large number of cells in the body, and the air and energy taken in from outside need to be pumped to the cells by a number of tubes, and waste products need to be collected by others. These tubes are the vessels of the circulatory system. The heart is the pump responsible for circulation within those vessels. The substance that flows in them is the liquid we know as blood, the fundamental component of which is water. The duty of the vessels is to carry essential substances such as oxygen, energy, nutrition, and hormones to every cell in the body. The total length of the average 5 billion capillary vessels in our bodies is some 950 kilometers. In some mammals, there may be as many as 3,000 open capillaries in just 1 square millimeter of muscle tissue. It is thanks to the low viscosity of water that blood is able to circulate in our vessels without becoming congested or slowing down. Michael Denton explains that if water's viscosity were just a bit more than what it is, the blood circulatory system would be completely useless. A capillary system will work only if the fluid being pumped through its constituent tubes has a very low viscosity. A low viscosity is essential because flow is inversely proportional to the viscosity. From this, it is easy to see that if the viscosity of water had a value only a few times greater than it is, pumping blood through a capillary bed would require enormous pressure, and almost any sort of circulatory system would be unworkable. If the viscosity of water had been slightly greater, and the smallest functional capillaries had been 10 microns in diameter instead of 3, then the capillaries would have to occupy virtually all of the muscle tissue to provide an effective supply of oxygen and glucose. Obviously, the design of macroscopic life forms would be impossible or enormously constrained. It seems then The viscosity of water must be very close to what it is if water is to be a fit medium for life. To put it another way, just like all its other properties, the viscosity of water is at the ideal level for life. Looking at the viscosities of different liquids, we see that they differ by factors of many billions. But water has been created at just the right level from all the billions of different alternatives.